Okay, so in this last video, we're going to work with another restriction for this radical function. So remember, the idea is we need to factor, find the zeros, and without a calculator, we need to graph the parabola. And all we care about is where the zeros are. So I'm going to take this guy and I'm going to factor it, and we have a leading coefficient, so factoring becomes a little bit more involved. These two numbers, the first and the last number, or the leading coefficient and the constant, multiplied together is negative 24. And if I multiply these two guys together negative 24, and what two numbers multiplied to equal negative 24 add to equal a positive 2, and that would be a positive 6 and a negative 4. So I'm going to go ahead and take my middle term, which is 2, and split it into that 6 and 4. I am then going to factor by grouping, so I split the middle, and I factor out a greatest common factor, which is 3x on the one side, and negative 4 on the other side. And then I get 3x minus 4, x plus 2. And so I set each one of these equal to 0, and I solve. So I have a 4/3 and a negative 2. So if we go through this and think about, so step 2 is we found the zeros, and I think about the graph of the parabola. Now, it's not a parabolic function, but what's inside is. So negative 2 would be here, and 4/3 is it's a very generic graph. I know this guy is positive, so I know it opens up. And so I know this is going to be the general shape of my graph. So I know that this is going to be all my positive y values for the inside. I know that's going to be all my positive y values on the inside. So these guys that I've identified with the black part of my graph is telling you that any number greater than 4/3 is going to give me a positive value in the radical. Any number less than negative 2 or equal to is also going to give me a positive value. These guys I can take the square root of. So that helps me with my solution. I know x is going to be greater than or equal to 4/3, or x is going to be less than or equal to negative 2. And that is my domain. And once again, notice how we're pointing. This guy is pointing towards the left, pointing towards the left, pointing towards the right, pointing towards the right. So a little bit of a pattern there. And that is how we're going to identify the domain of a radical function if we did not have a calculator. If you did have your calculator, you just plug it in, look at the picture, and look where the graph exists, and you've seen that in previous videos.